Hi everyone, I am Madam Rosmaya. Welcome to my YouTube channel. In this video, we are going to discuss on work done by the guests. Okay, so work done by guests. So we are going to derive and use the equation for work done by guests. So we are going to derive this equation. So work done is equals to the integration of P pressure with respect to V. V is volume. Okay, capital letter V is for volume. Okay, consider this situation, a container and with piston. Okay, a container with piston and the gas is trapped inside here, the container. Okay, so the cross-sectional area of the piston, let's say A, and then we supply energy by heating, okay, the container here. So what happened, the pressure will increase inside here. If to maintain the pressure P, so what happened, the piston will move to a distance. So the pressure, let's say P, so to maintain the pressure P, so what happened, the piston will move up. So let's say the distance move is dy. Okay. So from the force equation, force is pressure times area. Okay. So when there is a pressure, there is an area. So therefore, there also has a force. So that's why the piston move to the right. Okay. Okay. Now work dw equals to f dy. The work done generally the formula is work force times distance. So in this case there is a change in work, so dw equals to force force here and the distance dy. Okay, so we use work equals to force times distance, so we substitute into here, dw equals to f dy. Okay, then force is pressure times area, so we substitute into the equation here. Okay, then area times dy here is volume. Okay, so there is a change in volume because cross-sectional constant, but the distance here change, right? So therefore the volume also change, so we call this as dv. So area times the distance here will give you volume. So we write as P dV. Okay, next we integrate both sides. Okay.
Wait.
Yeah.
How do you get the PA dy to dV?
This one is imagine this is a cylinder. So it's a volume of a cylinder. Cross-sectional area times the height of the cylinder. Can you imagine that?
And W is what?
Work.
Work. Oh, okay. Sorry.
From form 4, form 5, work force time distance. Okay. Okay, then because we have two variables here, W and V, so it's in the separate, we separate the variable already, left hand side, W and V. So we can use integration rule. Okay, so take the integral both side like this, and integration 1 here means 1 with respect to W, work will give you work. Okay, so use integration rule here, you get work. And then for the right side, the volume change from V1 to V2. So V2 is the final volume. V1 is the initial volume. So we can write like this, from V1 to V2, then P dV. Okay, so this is the derivation of the work done in general. This is the work done. Okay, so next, now we are going to do further derivation for Boyles Law, Charles Law, and another one is the pressure law. So for Boyles Law first, for Boyles Law state that pressure is inversely proportional to volume. Okay, from Boyles Law. So P inversely proportional to volume. Okay, so when we put equal, we put a constant, P equals to K per V. Okay, remember the Form 5 topic, variation topic maths. So if you put equals, must put a constant. So the constant, let's say we name as K. So P equals to K per V. This is mathematics rule. Okay, now pressure. From this one, we are going to use this general equation for work. Work is integral from V1 to V2, P dV. So P, we substitute this P into here. So K per V. Okay, so now K is constant. So we can bring to the front, K constant. So leaving here is 1 per V. Okay, now we use integration rule to integrate this V to the power of -1. We cannot we cannot integrate V to the power of -1, right? So we use the other integration rule for 1 per V become ln V. Have you learned this in Maths T?
No,
We didn't
teacher.
learn this. Can
Can
you
you?
show the step, teacher,
Yeah,
beside
yeah, yeah.
the
Yeah, we
beside
haven't learned this one yet.
Oh, I don't want to show the step here. You will learn in Maths T later. I think end of this semester or next semester, not sure.
we are
Next
going to learn next
semester.
Next
semester.
semester.
Yeah.
Next semester, yeah.
Can you roughly show it?
I don't want lah because it's quite complicated to get ln V. Must use all the identity. So you just memorize. Okay, the integration of 1 per V is ln V. Okay, integration and what you call another one, derivation. Okay, you've learned in Sem 2, right? Maths T, Sem 2. So for integration of 1 per V, okay, memorize this, you will get ln V. Okay, for the step, you will learn later lah in the Maths T. Okay, then continue. So the V1 to V2, okay, we put here, then we substitute into here. What happened? So we substitute V2 first, so ln V2, then minus V1 into here, so minus ln V1. Okay, so ln V2 minus ln V1. We substitute this V1, V2 and V1 into here, so we get this. Okay, next we use log rule. Okay, log rule for minus becomes log V2 per V1. Okay, minus is division. If plus you multiply, but this one is minus, so means K ln, so division V2 divided by V1. Okay, okay, then we divide into 3 where for the case compression and expansion and where the volume not changes. So we divide into 3. Okay. So the first one for expansion. For expansion, what happened? Volume 2 will be larger than volume 1. Because the volume increase, right? Expansion. So that means the final volume V2 will be bigger or larger value than the V1. So what happened? For ln V2 larger than V1, so the answer will be always positive. Okay. So for expansion, the work done always positive. So memorize this. For expansion, the work done always positive. Okay. So for the next one is compression. Compression means the final volume will be less. Okay, V2 less than V1. So if you use log rule, for log rule, if 0 point something, the less means you get 0 point something. 0 point something. So for log rule, 0 point something will give you negative value. You can check with your calculator. Let's say ln 0.4 or ln 0.8, you will get negative, always negative. For ln larger than 1, here will be larger than 1 for expansion. Will give you answer always positive. For ln less than 1, will give you answer here always negative. Okay, so as a conclusion, if the compression process, the work done is negative. For expansion, the work done is positive. Okay, so what happened when the volume not change? So when the volume not change, so V2 will be equals to V1. So that means the ratio here will be 1. 4 per 4, 1, 5 per 5, 1, 100 per 100, 1, right? So ln 1 here, because V2 is equals to V1. So you will get ln 1. For ln 1, you will get 0. Okay, you can check your calculator. Ln 1 is 0. So for when the volume not change, so that's mean the work done is 0. Okay, work done 0 for no changes in volume. So memorize these three situation. Okay, so this is for Boyles Law. Okay. So next, what happened for constant pressure? Okay, another case. The first case done for Boyles Law. The second case is for constant pressure. For constant pressure, the P here, okay, we start with this equation. Okay, the P is constant, so we can bring to the front P. Just like Boyles Law, the K is constant, right? So we bring to the front. But this one, the P constant, so we can bring to the front. So leaving here, nothing means 1 here. Okay? So the work done is equals to P integration from V1 to V2 with respect to V. Here 1. So for 1, when you integrate 1, you get back V. Okay, integrate 1, you get V. This is integration, use integration rule lah, right? So here 1 means V to the power of 0. So use integration rule, so V to the power of 1 per 1, so you get V. So the volume change from V1 to V2, now we substitute into the V here. So that's mean V2 minus V1. Okay, so V2 minus V1 is the change in volume. We can rewrite as delta V. Delta means change in, so final minus initial. So this is another equation for work. Okay, so general equation for work by gas is this one. Okay, so the work now, what you call this equation now expand to 1, 2, 3. Okay, 1, 2, 3. Okay, for expansion, this one for compression will be negative, and for the constant pressure, so just P delta V. Okay, so memorize this 3 equation. Okay, so next, from now we continue. Continue. For work equals to K ln V2 per V1, okay, from this one. Okay, now we continue. No, we continue from here, constant pressure. Okay, work done, K ln V2 per V1 just now from Boyles Law. We divide into 3 also, expansion, compression, and V not change. Okay, so for the constant pressure also we do the same. We divide into 2, expansion and compression. Okay, for expansion, okay, same thing. The V is larger, V2 larger than V1. Okay, so what happened to this equation? Okay, that's mean V2 larger than V1, you get positive. So the work done always positive. Okay, because larger value minus lower value, you always get positive. So for compression also the same. The V2 will be smaller than V1. So if smaller than V1, what you get, the work will always negative. The work will always negative. So now compare these two situations for Boyles Law and for constant pressure. So both for expansion will give you positive value for work, and compression will give you negative value for work. Okay. So we can make a conclusion here. For both situation, expansion, the work will give you positive value. For compression, work will give you negative value. Okay or not? Any problem?
Teacher, I have a small question.
Yeah.
We use the ln V2 over V1 when pressure is not constant, right?
This one. Yes.
Yeah.
Pressure is inversely proportional to volume. So we use this one.
So why can we not just use that formula for both instances?
This one for constant pressure.
Mm-hmm.
For constant pressure, because from this is general equation for work. Okay. So when we substitute the P into here, this P is constant, so we can bring to the front P. Okay, not? So that's why the P times delta V only. The equation, the work becomes P delta V.
All right. Okay.
Okay. So the
Sorry.
yes.
Sorry, teacher. I want to ask you say that there's two situations, right? One is constant pressure. So we derive, we get P. Yeah, this one we get that one. Then if another one is not constant pressure, then what is constant?
So from P and V not constant, so T will be constant, temperature. Okay, temperature constant. Because Boyles law, temperature constant, right? PV and T, so temperature constant. So the changes is only in P and V. Okay, so we continue. Okay, so now we do further analysis on these two. Okay, on these two. Okay, so for the PV graph, remember Boyles law, the shape is like this, right? Okay, so the expansion means the arrow is in this direction. Okay, expanding. So the area under the graph will give you the work done. Okay, the work done. So integration, right? Integrations means area under the graph. So this one we call work done by the gas. Okay, work done by the gas. So work done by the gas is always positive. Whereas for compression, the arrow is this way. Okay, because volume shown by the represent by the x-axis. So for compression, it must be this way lah, direction. Okay, so this is compression. So the area under the graph will give you work, but it's negative value. Okay, so this is called work done on the gas. So very easy to memorize. On n is negative. By similar to sound p, pi by. So it's a positive. Okay, this is how to memorize lah. So this is our form 6 we use like this. If you refer to the other book, especially the university overseas book, so they are opposite. They derive by gas as negative and on as positive. But you stick to the form 6 syllabus. Okay, so by positive, on gas negative. On gas means compress, by gas means expansion. Okay, okay, any problem?
So that means that it is positive when the gas itself is exerting exerting a force, and it is negative when we are exerting a force back to compress the gas. Is that correct, teacher?
Yes, it's work done on the gas like we compress the piston just now. Okay, imagine the piston and the container. So you push the piston, so that one will be work done negative. So if you give yeah.
Continue. Sorry.
So if we give heat to the container, the gas in the container, so the piston move upward, right? Or to the left like just now. So it means that one is work done by the gas. Can imagine like that.
So like for example, in a car's engine, if I take during combustion, that is the energy by the gas, so that would be positive. And during when the piston goes down the chamber, that will be negative because the gravity acting on the piston is compressing back the gas.
Yes, but that one will more detail actually you will discuss. That one I think that one is in the when you go further your study at the university.
Okay. Are the values same, teacher? Just positive and negative values?
Pardon?
If the volumes are the same, when we are, let's say like a piston is the volume, it won't change, right? So we will just move the piston up and down. So does that mean the total amount of work is the same, just that it will be positive and it will be negative?
If the volume doesn't change, so the work will be zero.
No, I mean like how to say, like in a piston, when the gas expands from the combustion, the energy, the value energy there, and when the piston like will compress it back, the energy value given by the piston, will both of the energy values be the same, but like positive, negative, only difference?
Work done. Work done is positive and one is negative. So if the pistons is means moving down, volume decrease. Okay, means you push the piston, so the volume become decrease, right? So that one will be negative. So if the temperature increase inside the container, so what happened? There's a pressure in the container, right? So what happened? So the piston will expand, and the container will expand. The volume increase and push the piston up. So that one, the work done will be positive.
I see. Yep. Okay, teacher. Thank you.
Okay.
Sorry, teacher, I have a question. The arrow means what? The arrow means that the volume changed from 1 to 2, is it?
Yes.
Oh, okay. Thank you, teacher.
Okay. Okay, we do this example. It's in your book, A cylinder with a frictionless movable piston contains 0.15 mole of air at 25 degrees Celsius. So the piston is pushed slowly so that the air inside the cylinder remains in thermal equilibrium with the surroundings. So calculate the work done on the air if the final volume is 1/8 of the initial volume. Okay, so the R is given 8.31 joule per mole per Kelvin. Okay, so from this is the general equation for work. Okay, work equals to the integration from V1 to V2 P dV. Okay, so we given in the question number of mole 0.15. Okay, and then R. Okay, then temperature. Okay, then the volume. This is final volume lah. Initial volume, let's say V. Final volume is 1/8 V. Okay. Okay, now from PV equals to nRT, because here N and then RT, right? So we can use PV equals to nRT. So PV equals to nRT, we substitute into here. Okay. Where P is nRT per V, so we substitute into here. So we can bring all constant to the front. Okay, this is integration rules. So we bring nRT to the front. nRT leaving 1 per V. Okay, now we integrate this 1 per V becomes ln. Okay, becomes ln. So I skip the one step just now. Okay, straight away use ln V2 per V1. Okay, so the K actually nRT. From previous example, we use just K generally, but the K actually nRT lah. Okay. Okay, now we just now I repeat again the step from 1 per V becomes ln V2 per V1. What happened? So I repeat. Integration of 1 per V will give you ln V. So then we substitute V2 and V1 into here, becomes ln V2 minus V1. So use log rule, we get ln V2 per V1. So just repeat from just now lah. So you can use this equation. Okay. So nRT ln V2 per V1. Okay, now it's time to substitute the values given here into the equation. So number of mole is 0.15, R is 8.31. Temperature is absolute temperature, so convert 25 degrees to Kelvin. Okay, then final is 1 per V and initial is V, or you can use 1/8 V1 per V1. Okay, then we can cancel out the V1, so becomes 1/8. So the answer is negative, so you get negative. If you think of the logic here, 1/8 means decrease, the volume decrease. So when final minus initial, so the final will be smaller. So that means smaller minus bigger value will give you negative value. So negative, what does this means negative? Negative means work done on the gas. And the question here is written, calculate the work done on the gas. The gas here is air. That's why here on. Okay, work done on the gas. So it's logic to give you negative answer. Okay, that's all for my video. Thank you for watching. So please subscribe to my YouTube channel if you don't want to miss any of my video.